Here's something that should terrify you about the future of AI. The latest breakthrough that everyone thinks will solve our bias problems, it actually makes them worse.
I'm talking about agentic AI systems. These sophisticated agents that can use tools, search the web, access databases, and supposedly give us grounded, factual information. The promise is seductive. Even if the AI's training data is biased, it can just look stuff up, right? Use reliable sources. Get the real facts.
Turns out that's completely wrong. And the research proving it is absolutely fascinating. Welcome to Mindcast. I'm your host, Will. And today we're diving deep into what might be the most important revelation about AI that you haven't heard yet. This is a direct follow-up to our exploration of training data limitations. Remember our journey through the iceberg of knowledge? Well, today we're going even deeper. Because since that episode aired, some groundbreaking research has emerged that both confirms and completely transforms everything we thought we knew about AI's relationship with knowledge and bias. And the implications? They're staggering. So let's start with something that's going to flip your understanding of the problem completely upside down. Remember how we talked about Common Crawl and these massive web datasets being unreliable? Well, there's been this persistent myth floating around that even our supposedly gold standard sources, encyclopedias like Britannica, are less than 20% correct.
If that were true, you might think, well, maybe the training data problem isn't so bad after all. If everything is unreliable, then web-scale data is just as good as anything else, right?
Here's the thing. That 20% figure, it's completely false. And tracing where this myth came from reveals something crucial about how misinformation spreads even in academic circles.
The myth apparently stems from a distorted interpretation of a famous 2005 Nature study that compared Wikipedia to Encyclopedia Britannica. But here's what the study actually found. Britannica averaged 2.9 errors per article, while Wikipedia averaged 3.9 errors per article. The conclusion wasn't that Britannica was terrible, it was that Wikipedia was surprisingly good.
And modern research shows that today's Wikipedia is even better. A 2019 study found Wikipedia's accuracy in specialized topics like biology and medicine to be very high and on par with professional sources. We're talking about high-trust, carefully curated information.
So why does this matter? Because it completely inverts the problem. The issue isn't that our best knowledge sources are unreliable. The issue is that AI systems aren't being trained on these high-quality sources. They're being trained on the messy, unfiltered web, a corpus that is orders of magnitude less reliable than any encyclopedia.
Let me give you some concrete numbers to illustrate just how contaminated this web-scale training data really is. Remember Google's C4 dataset, the Colossal Cleaned Crawl corpus that powers models like T5? Despite aggressive filtering designed to remove toxic content, researchers found it still contained white supremacist content, conspiracy theories, and anti-trans propaganda.
But here's the insidious part. While the filters failed to remove harmful content, they successfully removed legitimate content from marginalized communities. Text written in African American English was flagged as low quality. Content about LGBTQ+ people, even completely non-offensive educational content, was filtered out because it contained keywords that appeared on crude, bad words lists. So the cleaning process actually made the bias worse. It created what researchers call a whitewashed version of English, systematically underrepresenting minority voices while failing to remove actual misinformation and hate speech. Now, this brings us to the big revelation, the one I opened with, because the natural response to all of this has been, okay, so the training data is biased, but what about these new agentic systems, these AI agents that can use tools, search databases, access real-time information? Surely they can overcome the limitations of their training data by just looking things up. This is what researchers call the decoupling hypothesis, the idea that you can separate reasoning from knowledge, that an AI's ability to comprehend and follow procedures is independent of the biases in its training data. It's incredibly seductive because it suggests there's a technological silver bullet for the bias problem.
But comprehensive analysis of over 180 research papers shows this hypothesis is false. And understanding why reveals something profound about how these AI systems actually work.
Here's the key insight. Comprehension in an AI system isn't a neutral mechanical process. When an AI understands a rule or instruction, it's not performing symbolic logic. It's doing probabilistic pattern matching based on statistical associations learned during training. Every concept, every word, every relationship, every way of thinking gets mapped to vectors in a high-dimensional space. And the positions and relationships of these vectors were defined by the statistical frequencies in that biased training data. The training data isn't just information the AI can recall. It's the probabilistic substrate of cognition itself. This creates what researchers call agentic confirmation bias. When an AI agent needs to search for information, it has to decide what to search for. That decision is generated by the same biased reasoning system. If the AI's training data suggests that certain groups are associated with certain problems, it will literally formulate search queries that retrieve sources confirming those biases.
There's a fascinating case study where researchers audited AI agents acting as news aggregators. When asked to research topics, the agents consistently formulated queries that retrieved sources aligning with the consensus view from their training data. They functioned as automated echo chambers, surfacing significantly fewer unique outlets than neutral searches and skewing toward Western institutional sources.
Even when these systems successfully retrieve unbiased information, they often can't properly integrate it. There's something called context parametric conflict. When retrieved data contradicts the AI's pre-training beliefs, the AI often prioritizes its training over the evidence, especially when those beliefs are strongly held stereotypes or common misconceptions. And get this, sometimes the AI will actually hallucinate details into retrieved text to make it fit its preconceived notions. If a biography of a female scientist doesn't mention her family life, a biased system might hallucinate that she balanced career with family, because that's the expected statistical completion for female biographies in the training data.
Now, let's talk about what this actually means for the real world. Because this isn't just an abstract technical problem. These systems are being deployed in healthcare, hiring, legal systems, and education right now. In healthcare, AI systems trained on datasets that historically excluded women and minorities learn biased patterns. When a Black female patient reports shortness of breath, the system might retrieve information about both heart attacks and anxiety. But due to the training distribution, it assigns higher probability to anxiety. The tool didn't fail. The prior corrupted the reasoning. In legal systems, AI trained on historical case law learns discriminatory sentencing patterns as patterns of justice rather than patterns of bias. When asked to recommend sentences, it effectively launders historical racism through seemingly neutral procedural tools.
In hiring, AI systems trained on web-scale employment data learn to associate certain names in universities with success and others with risk. When summarizing resumes, they hallucinate or emphasize different details based on race and gender cues, judging career gaps more harshly for women, for instance. The common thread? These systems follow their procedures perfectly. They search for information, they retrieve data, they follow rules. But their definition of concepts like qualified, healthy, or innovative was shaped by biased training data. The procedure acts like a phantom firewall. It looks like protection, but the bias flows right through. So where does this leave us? I want to give you 3 concrete takeaways from this research that I think are absolutely crucial for anyone trying to understand the future of AI.
The solution isn't better algorithms, it's better data. You cannot code your way out of bad training data. All the sophisticated reasoning models, all the tool-using agents, all the retrieval-augmented generation systems in the world won't fix a foundation built on biased information. Studies consistently show that smaller models trained on curated, balanced data outperform larger models trained on raw web data when it comes to fairness and reasoning.
Second, the field needs to move from web-scale scraping to deliberate curation. Remember how we talked about the pile in our previous episode? That dataset represents a philosophical shift from automated filtering to human-led curation of high-quality sources. The future of trustworthy AI lies in building models from smaller, domain-specific, carefully vetted datasets, rather than trying to clean the entire internet. And third, we need to fundamentally change how we evaluate these systems. Current benchmarks often miss structural biases because they focus on factual accuracy rather than representational fairness. We need evaluation methods that explicitly test for agentic confirmation bias, context parametric conflict, and bias leakage in tool use.
Now, I want to be clear about something important. This research isn't saying that agentic AI systems are useless or that we should give up on them. What it's saying is that we need to be honest about their limitations and stop pretending that procedural rules and external tools can magically neutralize the biases baked into their cognitive foundations. These systems can be incredibly powerful and useful when deployed with appropriate humility and safeguards. They're excellent at updating factual information. If you need to know the current population of Tokyo or the latest stock prices, tools can absolutely help with that. But when it comes to complex judgments, nuanced reasoning about people and societies, or decisions that affect human welfare, the training data matters enormously. The phantom firewall metaphor is perfect because it captures something crucial. The illusion of protection can be more dangerous than acknowledged vulnerability. When we believe that agents and tools have solved the bias problem, we become less vigilant, less critical, more likely to deploy these systems in high-stakes situations where their hidden biases can cause real harm.
This connects back to everything we discussed in our original training data series. Remember the iceberg of knowledge? The vast amounts of human knowledge that never make it into training data sets because of legal barriers, cultural sovereignty rights, or simple digitization gaps? Those exclusions don't just create knowledge gaps, they create systematic worldview distortions that no amount of post hoc tooling can fully correct. The path forward requires acknowledging this fundamental incompleteness and building systems designed around humility rather than omniscience. It means training AI on carefully curated, transparently sourced, representatively balanced datasets rather than whatever happens to be freely scrapable from the web. Most importantly, it means changing the conversation about AI from how do we make these systems smarter to how do we make them wiser? And wisdom, as it turns out, isn't about processing more data or using more sophisticated tools. It's about understanding the limitations of your knowledge and the biases of your perspective. So here's my challenge for you. The next time someone tells you that AI bias is solved because the system can just look things up or use external tools or follow objective procedures, I want you to remember what we've talked about today. Remember that reasoning and knowledge are entangled, that comprehension isn't neutral, and that tools are only as unbiased as the minds that wield them. The future of AI depends on our willingness to look past the phantom firewall and grapple with the hard work of building better foundations. Because in the end,
You can't engineer your way out of biased data. You can only acknowledge it, measure it, and choose to do better. That's our exploration for today. I'm Will. This has been Mindcast. And as always, the most important questions about technology aren't technical. They're human. Until next time, stay curious, stay critical, and remember that the future is what we choose to build.